All right, our last lesson of the chapter, and the last lesson I'm going to teach you from Algebra 2, yay! Geometric sequences in series. A store offered customers 2 plans for getting bonus points. 10 points a day, and then you get twice as many points the day before, or then 1 point a day, and then 3 times as many points the day before. What expression represents the number of points received each day for plan A? That's easy. You start with 10. Oops, I don't want to say it. Yeah, we start with 10. And then we multiply by 2 power of x. How about for part B? Start with 1 point, 3 power of x. Boom. On the 7th day, which plan would offer the most points? Well, let's plug in 7 for x. 10 times 2 to the 7th. The other one, 1 times 3 to the 7th. If we use good old Desmos to do this, let's figure it out. Okay, so 10, 2, 7, 1280. 1, 3, 7, 1280, 2187. So it looks like the second one's a lot better because it's tripled, even though you're starting with a smaller number. So this is 1280 and 2187. So I'd rather have that one because I'm tripling my points, even though I'm only starting with 1 point. Any questions? Good, because I can't hear you anyway. Geometric sequences. Remember that geometric sequences are multiplying by the same number, okay? So notice 4, 12, 36, blah, blah, blah. To find it, remember, we divide the second number over the first number. So it's 12 over 4, it's 3. There's your base. So we have our equation. Since we're starting off with 4, 4 times 3 to the power of n minus 1, bam, you're done. Easy. That's simple, kids. That is explicit, by the way. We're going to talk about, and I think I brought this up with explicit and recursive, okay? Recursive is really simple. You start with the first number, and whatever you're multiplying with, that's going to be your next number. And we've done this before a million times. Why? Because it came from our SBAC review. Here we go. It's this simple, guys, okay? So for this one here, is this sequence geometric? Well, we got to see if we're multiplying by the same number, right? So this divided by this, 0.8. This divided by this, 0.8. This divided by this, 0.8. It is, so we're good. So the number's 0.8. First number 12, bing, bang, boom, we're done. So there we go. Is this sequence a geometric sequence? Let's prove it, okay? 1.45, I'll do this party over here. 1.45 over 1.22. Let's use good old decimals to figure that out. Boop, boop, okay? And 1.45 out of 1.22. Okay, 1.1, that's gonna be a funky number. Let's check the next one here. 1.68 over 1.45. And it's not. So it's not geometric. Okay. So this is 1 point, let me check it again. 1.18, 1.16. And the other one, 1.68 over 1.45 was 1.16. So this is a no. This is also not geometric. You know what? It might be. And the reason why it might be is because we are going to get a negative answer. Okay. So let's do part B over here. Okay. 0.75 over negative 1.5. Okay. That is going to equal, let's check it out real quick. Okay. Boop and boop. Okay. 0.75 divided by negative 1.5. It's negative 0.5. The next one, okay. Let's see. Negative 0.375 over 0.75, and that is also going to get you negative 0.5. So this is a geometric sequence. So I'm going to put the answer over here for part B, and I'm going to put this in, let's go vomit green. Okay, so if I put the recursive stuff here, we start with negative 1.5 when n is equal to 1, and I multiply the next number by negative 0.5. So it's negative 0.5 a sub n minus 1 when n is greater than or equal to 2. When n is greater than or equal to 2. Okay, there you go. Not difficult. Okay, now if I want to go from recursive to explicit, simple. First number, base, bam, you're done. I can't even kid you how easy that is to go from recursive to explicit because we've done this a million times. Okay, now given the explicit, let's predict what is a recursive? Well, again, First number, base, bam, simple. That simple. Part A. Let's go from recursive to explicit. 12, 1/3, n minus 1. Done. Explicit to recursive. First number is 6. Okay, and you're multiplying by 1.2. There you go. Done. That's it. If you guys think, that's how I'm gonna feel if you guys find this difficult. Okay, no questions. Not taking questions, even though I can't. A phone tree is when one person calls a certain number of people, then those people each call the same number of people, and so on. In the 5th round of calls, 243 people were called. Write an explicit definition to find the number of people called in each round. Well, we know the first number is 3, okay? Because we're starting off with 3. Then, notice how we're going from 3 to 6, and then 6 to 12, essentially, because we're multiplying by 2. Or are we? Not sure about that. We know that the 5th round of calls is 243. We need to find it. We know the first number is 3, though. That we know for a fact. And when n is 5, the answer is 243. So notice what's happening here, okay? We say n equals 5. The first number is 3. And then the answer to the 5th number is 243. So I'm using that information to find the value of the base, and then I cubic root it, or sorry, 4th root it, I get 3. So then we have our equation here, right there, okay? So after that, once we make our equation, how many people were called in the 8th round? Just plug in n, 8 for n, and we have it. So let's look at this here, okay? A geometric sequence can be used to describe the growth of bacteria in an experiment. On the first day, and this is actually really important, because notice that 3 to the 20th, we're gonna need that. On the first day of the experiment, there were 9 bacteria in a petri dish, but on the 10th day, there were 3 to the 20th bacteria. So that's what we're gonna set the equation equal to. After, or once we do, then we can find how much there are in the 7th day. So let's find the equation first. Okay, so step 1, let's find the equation. Okay, 3 to the 20th is equal to 9 multiplied by r to the, and it's gonna be 10 minus 1. Okay, that's important. Okay, or to the 9th. So here's the kicker. Okay, 3 to the 20th, I can actually change 9 into 3 squared. And I'm going to show you why. I'm going to divide this by 3 squared. 20 minus 2, that's 18. Okay, remember, when we divide, we subtract the exponents. R to the 9th. To get just R, everything gets risen to the 1/2. 18 divided by, not 1/2, wow, 1/9, because I want to make that a 1. My bad, guys. Ignore what I just said. It's 1/9. 9 divided by 9 is 1. 18 divided by 9 is 2. So it's 3 squared equals R, or 9 equals R. So we have our equation now. Okay, I'm going to put this on the side here. This means A sub n is equal to 9 multiplied by 9 to the n minus 1. And if I want to find out how much bacteria is in the 7th day, just plug in 7. 9, 9, 7 minus 1. That's it. And then we can use Desmos to find the answer. Erase this here. How can I start erasing? There we go. Okay. 9, 9, 7 minus 1. That's it. That quick, that simple. Okay. But again, you need to have the first number and then another number after that by using that sequence. Okay. This one's actually, it's a little difficult to find the sum of a geometric series. It's going to be included in the homework, but I don't think I'm going to quiz you guys or test you guys on this, but pay attention to this. If a sequence is geometric, and if I want to find the sum of an entire geometric sequence, notice the formula that we're using. It's the first number multiplied by 1 minus what we're multiplying by to the power of n, how many numbers we want to find, over 1 minus r. So for this one here, write the expanded form of the series. I'm not even going to have you do that. That's a pain in the tuchus. Just focus on this, okay? Because from here, we need to find the sum of it. And the sum of it is just this. First number, what we're multiplying by, and that's it. That's all you're using. So we don't need to expand it. I'm not even gonna have you guys bother expanding it, okay? So ignore the expanded form, but let's just find the sum, okay? I'm gonna put the formula here on the top again. So to find the sum of a geometric sequence, first number, 1 minus r to the power of n, which is what you're multiplying by, over 1 minus r. Let's fill in the numbers, okay? We know the first number is 1/2 in this, okay? Multiplied by 1 minus 3 to the power of 5, okay? That number on the top is how many numbers we want to find. Over 1 minus 3. There you go. That's your first part, okay? Ignore part B. I'm not even gonna have you guys focus on part B. It's just too much of a mess, okay? We have 2 more actually. Oh, actually, it's not that bad. Okay. Okay. How many terms are in the geometric sequence of this? Okay. So I know that when I divide 300 by 200, I get 1.5. And I know the last answer is that. So I'm going to set the equation that I have. This is, again, the first number. That's what I'm multiplying by, setting it equal to the final number. From there, I use log to drop the exponent, and this is going to be my exact, right here. This is my exact answer at the end, okay? Now for this one here, the sum of a geometric sequence is this. The first term is 3, and the common ratio is 5. How many terms are in the sequence? Well, I use the geometric series equation to find out how many terms there are, and I choose that equation after that, okay? So let's do this on a separate sheet of paper, okay? How many terms in the geometric sequence? 3 plus 6, blah, 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 plus 768. Okay, here we go. So I know that 6 over 3 is equal to 2, and I know I had the last answer is 768. So 768 is equal to 3 times 2 n minus 1. Okay, when I divide both sides by 3, 768 divided by 3, I get 256. 256 equals 2 to the power of n minus 1. I attach a log to both sides to drop the exponent. So log of 256 is equal to n minus 1 times log of 2, okay? And I'm going to do everything in one final step, okay? So it's log of 256 over log of 2 plus 1 equals n. And the reason being is because I divide log 2 and then add 1 to both sides at the end. Okay, so that covers that there. This one here, the sum of a geometric sequence is 155. The first term is 5 and the common ratio is 2. Let's use the equation. I know the sum is equal to 155, okay? It's equal to, let's go back to this. The first number is 5, so it's 5. Multiplied by 1 minus, the common ratio is 2, okay? Over 1 minus 2, which we get negative 1. It's 5 multiplied by 1 minus 2 to the power of n over negative 1. When I cross multiply, I get negative 155 equals 5, 1 minus 2 to the power of n. N is inside actually, my apologies there. I divide both sides by 5. Okay, we get 31, so it's negative 31 equals 1 minus 2 to the power of n. I'm going to move the 1 to the other side, then divide by a negative, so I get 32 equals 2 to the n. And since we've got an n right there, we can treat that as x. That means n equals log of 32 over log of 2. That's it. All there is to it. Okay, last example, then we're done with Algebra 2. Okay. Oh boy. Isabel wants to borrow a $24,000 loan for 6 years with an annual interest of 4.5% to purchase a share in the food truck business. What will be your monthly payment? We're using this equation here. Oh boys, oh boys, oh boys. Well, that's actually not that bad. So we need to figure out what this number is here, okay? So in this case, it's 1 over 1 plus all of that to the power of k. Let's see here. Oh, I know why. I know why. So the denominator is a finite geometric sequence. If I subtract this from 1, that's why we get 0.996. So that's going to be our first number. okay? And then the next number is we multiply each number by 0.996, and then we have that there. It's actually not terrible. It's actually not terrible. Let me see something here real quick. Oh, because you want it monthly. Oh, okay, that makes sense. So you have to go over 12. So this means when I rose 0.045 to the 112, that's how you got this. That makes sense. Okay, let's do this here. I'll make this very quick. Okay, so it's the sum of 48 months. Okay, because there's 4 years, 12 months in a year. 40,000 over 1/1 plus, and let's convert 0.048 to the power of 1/12. Let's use Desmos for this. Okay, 0.048 to the power of 1 divided by 12. It's that seems very big. 0.776. Huh. 0.048 to the power of 1/12 should be a way smaller number than that. Nope, actually that seems about right. Okay. It seems rather odd that it's that. Oh, you have to divide it by 12. That makes sense. My bad, kids. We have to divide 0.048 by 12. Oops. There we go, divided by 12. That's what I wanted, 0.004 is what it should be. So let's go back to this. I forgot that we divided by 12. So it's 0.045 divided by 12. My bad. 0.045 over 12 gave us this. Whoops. So then in this case, okay, it's going to be 1 minus 0.004. Okay. So if we go back to this right here, okay, 1 minus 0.004, that's going to be 0.996. Okay. In this case, what happens now, this is to the value of k right here. Okay. So now what happens here? Okay. 0.996 multiplied by 1 minus 0.996 to the power of n over 1 minus 0.996. Okay. I'm going to erase this. This is 0.048 divided by, I won't even erase. How about that? Okay. Then to finish this off at the end here, okay, basically it's this number under 40,000. So I'll put the final answer over here. Okay. The final answer is going to be right here. It's 40,000 over big parentheses 0.996 parentheses 1 minus 0.996 to the power of 48. That's important. Okay, over 1 minus 0.996. And again, the reason why it's 48 is because 48 is the last number that we're working with here. Okay, so there we go. I have our final answer. We're officially done with Algebra 2. That was the last section of the chapter. Okay, this is just a little food for thought. Some of this won't get covered on the test. Some of it will. So get ready. So enjoy Chapter 6.